So now that we have the basics of the parametric equations down, right? We know how to find intercepts, we know how to graph it, we know how to convert it into rectangular form. We can actually do an entire example. So we have this example here about a projectile moving so that its position in feet at any time t in seconds is given by those equations. X equals 60t and y equals 80t minus 16t squared. And they want us to sketch a path of the projectile. And they give us a window to use. So what we can do is we can take our equations and enter them into the calculator for x1 of t and y1 of t. So x1 of t is 60t and y1 of t equals 80t minus 16t squared. And if anyone's ever done physics, this is the kind of equation you'd have in physics because you have like a horizontal component of the velocity and a vertical component of the velocity, right? So the horizontal is the x equals 60t. This just means that it's going horizontally at a speed of 60 feet per second, right? And the y equals 80t minus 16t squared. Well, the 80 is the initial velocity upward, right, in feet per second. And that negative 16, if you remember this from physics, is the acceleration due to gravity, right? That's going to make it come back down to Earth. So that's our parametric equations. We'll put in the window of, well, with t, and see now this case, this is where you have to think a little bit, right? So t in this case is the time. So the time in this case starts at 0 when the projectile is launched or whatever, right? And how long is it going to go for? Well, it's basically going to go until it hits the ground. So I guess maybe we can go until like 5 seconds. That should be enough. And they'll tell us to use the window 0 to 300. And you probably want to go by like 50s there with this scale. And then 0 to 200. And we go by 50s again on the y. Right? So you see the window is much bigger in parametric because you also have the t to worry about, right? So if I now graph this, again, I want to use that one with the little circle on the end there. That one. Graph it. Oops, I have a stat plot on. Huh, it looks like I chose the exact perfect uh, t to use, right? It looks like it might land back at 5 seconds there. Let me shut off the stat plot here. So there it is. There's the motion of the projectile. And the other thing to remember here is normally when we do these motion problems with just x and y, there's no um, horizontal distance involved. It's just time is the x and height is the y, right? So this time here is kind of like something that you don't see, right? So that's where time is 0. That's where time is 5. But the x is really the horizontal distance and the y is the vertical distance. So this is actually a lot more useful than our old uh, height problems, right? It's a lot more useful. Get more information out of it. So there we go. So that's the graph of the path of the projectile. So how long will it take for the projectile to strike the ground? Well, we can use the calculator for this, or we can realize, hey, well, this thing is going to strike the ground. What that means is, when is it on the ground? It's on the ground when y equals 0. So what we could do without the calculator, right? I mean, we'll use the calculator afterwards, but what we would do without the calculator is we'd say, all right, well, y equals 0. So replace y with 0, and we get this. And just solve this now for t, right? So 16t squared, oops, minus 80t equals 0. And what you can do is you can take out from this a 16t. And when you take out a 16t, what's left is t minus 5. So you end up getting 2 times where the height is 0 at 5 and at 0, right? But 0 isn't what we're interested in here because this is actually the launch time. So we don't care about that. What we do care about is the 5 seconds. So that's how long it takes to strike the ground, 5 seconds. And then the other question now is, what is the height of the projectile when it has covered a horizontal distance of 120 feet? And again, this is where you got to think a little bit, right? So horizontal distance of 120 feet, right? The x is the horizontal distance. So what we first want to do here is we want to find the t value when x is 120. So the x equation was it x equals 60t? Yeah, was x equals 60t. So we're going to have 120 equals 60t, and this is easy enough, divide by 60, and we get 2 seconds. But are we done here? No, because they're asking what is the height when it has covered a horizontal distance of 120 feet. Well, we know it's covered a horizontal distance of 120 feet at 2 seconds, but we now have to find the height at 2 seconds. So what you really want to do here is find y when t is 2. So you might call this y of 2, right? Find the y value at 2 seconds. And the y value at 2 seconds is going to be 80 times 2 minus 16 times 2 squared. So this is going to be 160 minus 64, which is going to be 96. So it's going to be 96 feet. So when it's covered a horizontal distance of 120 feet, it's still at 96 feet. And the only other thing that would have been useful probably to ask here is the same kind of question from part B, right? How long will it take the projectile to strike the ground? All right, well, 5 seconds. And then the logical follow-up to this would have been, what's the total horizontal distance covered? And how you would find that is you just plug in 5 for the x value. I'm sorry, for the t value in the x equation, right? So we'd have x equals 60 times 5, which is 300 feet, right? So the total horizontal distance covered is 300 feet, right? So after 5 seconds, it lands 300 feet from its initial location, right? So yeah. So some of these require a little bit of interpretation, right? You have to interpret what the horizontal distance being 120 feet means. You have to interpret what striking the ground means, right? It means that y equals 0, so on and so forth. Okay? And this one would have been another one that would have been straightforward enough to just turn into the rectangular form. You could just solve the x equation for t, and then plug that expression in for t there, right? And you'd have your rectangular form.